So again, the force from the pressure of the heart pumping is going to force blood through the afferent arterial and through the capillary so you get filtrate out. But there are some opposing pressures that may pull fluid back in. One of those being osmotic pressure of the capillaries here, because one thing that's present here that you won't see in the filtrate is protein. So water is very attracted to protein. So water is going to want to go back in here. The only thing is that it's 55 millimeters of pressure out, but only 30 attracting in. So still your net movement is outward to make the filtrate. Now there's a little bit of pressure from the filtrate that's here in this capsule pushing up against the capillary, so it could allow some water to go back in. But even the osmotic pressure plus the pressure from the filter outside only accounts for 45 amounts of pressure coming in. Still 55 going out, so still meaning that your net pressure is moving outward. That way you can filter out and keep it moving that way. Now, if your blood pressure was super low, then that could be lower than your inward pressure. And therefore, you wouldn't have enough filtrate going out. You'd have more of the pressure of it coming in, which is why the kidney needs to be able to regulate its blood pressure quickly. So as soon as blood pressure drops too low that it affects glomerular filtration rate, this vessel will open up to allow more blood in to increase that pressure to allow it to push it out. Yep. So this is our nephron model. If you look at these vessels here, that's your main blood supply here. So that's going to be coming from the renal arteries or going to the renal veins. And so you can tell what is afferent or efferent arterioles by it's coming from the main blood supply. So the main blood supply would be the afferent arterial. Because if you remember when we talked about trace drop of blood flow, it went from the aorta to the renal artery and then eventually to the afferent arterial. So that's coming from the main blood supply. So afferent arterial here, glomerulus would be inside this corpuscle right here. This is the renal corpuscle. And so the glomerulus would be inside here, and then blood would flow out through the efferent arterial. Also, you can see different types of nephrons here. This is a cortical nephron here at the top. You can tell because it's higher up in the cortex and the nephron loop is small. Okay. This guy right here is a juxtamedullary nephron, and you can tell because the bulk of the nephron is closer to where the medulla is. This is medulla, this is cortex. So it's closer to that junction. And also the nephron loop is much longer than what you see with a cortical nephron. And so we said that cortical nephrons are associated with peritubular capillaries and juxtamedullary nephrons are associated with the vasa recta. So again, with blood flow, afferent arterial, glomerulus here, efferent arterial, and this would be all peritubular capillaries that eventually lead to the renal vein and eventually to the inferior vena cava and back to the heart. Okay. And so on this side, again, from the main blood supply, that would be afferent arterial, glomerulus here, efferent arterial out, and then these capillaries would then be a vasa recta because this is a juxtamedullary nephron. Okay. And so eventually, after the vasa recta, eventually goes through the vein side out through the renal vein to the inferior vena cava back to the heart. As far as the tubules go, so renal corpuscle is here with the glomerulus, and then the capsule is going to eventually turn into the proximal convoluted tubule. You can tell that the gray is what's attached to the glomerulus. So the gray is the proximal convoluted tubule, and I'll use this one over here. Gray is proximal convoluted tubule. This would be the descending limb of the nephron loop, the actual nephron loop, the ascending limb of the nephron loop, and then there's the distal convoluted tubule. And that's leading to the collecting duct, which is eventually going to go to a minor calyx. Okay. And on the other juxtamedullary nephron, it's going to be the same thing. The capsule and the corpuscle are here. So then we're going to go proximal convoluted tubule is the gray, descending limb of the nephron loop, ascending limb of the nephron loop, distal convoluted tubule into the yellow collecting duct, and eventually to a minor calyx, which will go to a major calyx, which will go to the renal pelvis, and then the ureter, and then the urinary bladder, and then the urethra out the external urethral orifice. And that's it.
Wow.